Alright guys, this next part is about special products. Now we've actually looked at these before. You've heard of difference of two square pattern and the perfect square trinomials. So the only one that we really need to concern ourselves with is the difference of two square pattern, because perfect square trinomials kind of work themselves out naturally. So anytime you have a difference of two perfect squares, it's going to factor into our conjugates a plus b and a minus b. Okay, think back to when we did conjugates. A squared minus b squared is going to give us a plus b and a minus b. So, one quick little fact, this only works for differences, not sums. Okay, if it doesn't have a minus, you cannot use this pattern. You have to have a minus in between those perfect squares. If they're not both perfect squares, it's not going to work. So let's look at an example, number 1, y squared minus 9. So it only has two terms. So this is going to kind of clue us into A, look for a GCF, and B, see if it's a difference of two squares. So y squared is a perfect square. It's y times y. 9 is a perfect square. It's 3 times 3. So that means this is a difference of perfect squares. So this is going to factor into our pattern y plus 3, y minus 3. Because when we check it back, y times y is y squared, 3 times negative 3 is negative 9, and when you check the middle, notice these two terms cancel out. They end up being 0. That's because these are conjugates. So this would be our factor pairs for this polynomial. So number 2. 4x squared minus 25. So first thing we check for, is there a GCF? 4 and 25, no GCF. See if it's a difference. It does have a difference of some amount of minus in between it. So now we need to see if 4 and 25 are perfect squares. And you should know that these are 2 times 2, 5 times 5. And more importantly, this is 2x times 2x. The x has to be a perfect square too, because if this is just 4x, then it wouldn't work. Okay, so 2x and 2x and 5 and 5. So when we go to write this special product, we say 2x and 2x plus and minus 5 and 5. Those are our conjugates. Okay, so number 3, 64p squared minus 16. So I know what you're thinking at this point. Hey, those are perfect squares. 64 is 8 and 8. 16 is 4 and 4, and you're right. But you have to check for a greatest common factor. So when you look at 64 and 16, they have a greatest common factor of 16. So that means a 16 comes out, and that leaves us with a 4p squared minus 1. Okay, now these are still differences of perfect squares. They're just a lot smaller. So 4 is 2p and 2p, and 1 is 1 and 1. Remember, 1 is a perfect square. 1 times 1, and then we have 2p times 2p. So this is going to factor into 16 times 2p plus 1 times 2p minus 1. Now, if you didn't factor out the greatest common factor, you might have tried to put 8p minus or plus 4 and 8p minus 4. And you would see that, hey, look, these have a greatest common factor of 4, so a 4 would have to come out. And these have a greatest common factor of 4. So 2 4s have to come out, which multiplied together gives us 16. So this is the factored completely form. This is partially factored. So this would not be enough because you have to factor completely. Okay, so number 4, 3m squared minus 48. Now, I'm sure the first thing you're thinking is, hey, those aren't perfect squares. And you are right. 3 and 48 are not perfect squares. But they do have a greatest common factor. So in this case, the greatest common factor is 3. And that leaves us with 3 times m squared minus 16. So I want you to go ahead and finish factoring that one when you're ready to turn the video on. Alright, so here's our answer. 3 times m plus 4 times m minus 4. And again, checking. 4m minus 4m is 0 m's, and this doesn't have any m's, it's 0 m's. Okay, so these are conjugates. All right, the other one is the perfect square trinomials. And I told you this one isn't a huge deal because it kind of happens naturally. So let's just jump into an example. X squared plus 6x plus 9. Okay, so factors of x would be 1 times 1. That would be the only numbers in front. Now 9 has 1 times 9 and 3 times 3. Now on this one, you want to start with the smallest numbers. And if they have a set of perfect squares, that is a really good place to start. So we have x and x. The signs are going to be the same and they're both going to be positive. So plus and plus. And when I choose 3 and 3, notice I get 3x and 3x. And that adds up to my 6x. This is what we call a perfect square trinomial. And we've seen these before when we were multiplying things out. The only difference with this problem and the ones we've been doing is that our final answer may look a little different. So our final answer, because these are the exact same factor, we generally write them as x plus 3 to the second power. It's just a little shortcut so we don't have to write both factors out. So here would be our final answer, x plus 3 squared. So I want you to try number 6. So 49 x squared plus 14x plus 1. So factor that out, and when you're ready, turn the video back on. Alright, so this number looked a little intimidating, I'm sure, but 49 is a perfect square. So you really want to start with the 7 and the 7, and then 1 is just 1 times 1. So 7x is 49x squared. 1 times 1 is 1. And then underneath here we have 7x plus 7x, which adds up to 14x. And again, we would write our final answer as 7x plus 1 to the second power because these are the exact same factor. Okay? Alright, so that's the end of this video.